This video clip is to look at different topics that are covered in section 4.2 homework, which deals with finding the mean, estimating a population mean given an interval. First of all, we want to look at a few problems that are used in this section. First one I want to look at is problem number 2, which asks you to compute the critical value z alpha divided by 2. Notice it corresponds to a 93% confidence level. So let me show you an example of this. If I have a bell-shaped curve, it doesn't look too great, but you get the idea. What that's telling me, if it's 93%, the 0.93 is in the middle. And what happens is we need to find this z-score. Okay, so what we'll need to do is find the alpha, which is the total of these two shaded areas, and divide them in half, and then we can use inverse norm on our calculator. So let's go back to the problem and look at this. Let me pull up the calculator. So I'm doing, let me turn it on first, that would help. We're doing 1 minus 0.93. That's the area in the middle. And notice the alpha on the both ends is 0.07. Notice our formula is wanting to take the alpha and divide it in 2. So on each end we have an area that's 0.035 on each end. We need to find the critical value for this area. So I'm going to use my calculator and do second vars, go to inverse norm number 3, and type in 0.035. Now remember, the area that we want is a positive z-score. So notice in our problem, we're getting the z-score on the left. We need the one for the right. So we'll make this a positive 1.81. So let's check this, 1.81. We type it in, and we have it correct. Now, the next problem, number 3, I want to look at. Several people are missing this because they're not reading what it says. They're just wanting to know if the necessary requirements are satisfied to be able to use a z. Now notice it says calculate the margin of error if the necessary requirements are satisfied. But first of all, you got to decide if the necessary requirements are satisfied. The main thing we're looking for first is see if it's normally distributed. Notice when it's normally distributed, it does not matter the size of n. Okay. Also, we are given a standard deviation of a population. When we're given a standard deviation of population and it is normally distributed, that's when we use z. You use t when the sample standard deviation is given, not the population. I always think S goes with T. And either N has to be greater than 30 or it has to tell you that it's normally distributed. So in our case, yes, we can use Z because the standard deviation of population is given and the original population is normally distributed. Now they want you to calculate the margin of error. So to calculate the margin of error, we'll need to use the z-score for 95%. If you look at your positive z-score table, let's see if I can find it. I think it's here. There we are. If you scroll down to your positive z-score table, down at the bottom right-hand corner, here are some of the values that have been calculated for you. And if we're using a 95% confidence level, our critical value is 1.96. So this is 1.96. We know our standard deviation of population. We know our sample size. So let's pull the calculator up and let's type this in. So z is 1.96 times our standard deviation of the population is 12. Push enter and then divide by the square root of n. And n in this case is 26. So close it up, hit enter. And notice this is our margin of error. This one asks us to round to 3 decimal places. So we have 4.613. So let's type that in. 4.613. We can check our answer. Okay, so I wanted you to see sometimes it's just going to ask you if the requirements are met to work the problem. If they are, then it will ask you to work the problem. Let's go and look through some of these. Notice this one asks you to find sample size, and the key here is it talks about the mean and it talks about sample size. So if we look at our formula sheet, we need to go to the sample size formulas, which is located here, and we need to use the one that's for the mean. So you can use that formula. You know how to look up your z. Notice this standard deviation can either be a sample standard deviation or a population standard deviation. Either one in this particular formula. Let's see what else we have. Whoops, wrong one. Okay, let's see. I'm just looking through and see if there's some that I know that you may have trouble with. Notice this is asking you to find the minimum sample size. So that's using the n. Oh, a key, always when you're finding sample size, always round up to a whole number. This is another problem. It's not anything to work. They're just asking you a question. And anytime you're talking about a point estimate, the best point estimate for a population mean is the sample mean. So all you have to do is look up the sample mean and write your answer. This one, they're asking you to find mean and find your margin of error. The mean and the margin of error. There's a formula for this. If you're trying to find the mean, let's pull our calculator up. You will take the upper bound, or the upper limit, plus the lower limit and divide by 2. So in our case, we have 23.397 plus 20.983. Push enter and divide by 2. So we find out that the sample mean was 22.19. Now remember, it's the sample mean plus the margin of error that equals this value. So now that you know the sample mean, you can subtract it from your upper bound and it will give you your margin of error. Or you could subtract the two interval values and divide by 2 and it will give it to you also. But this is the faster way of doing this. So our margin of error is 1.207. Okay, so now when we type this in, we have 22.19 and we have a margin of error of 1.207. Now you could check this by adding the two numbers and seeing if it gives you this value, or subtract the two numbers and see if it gives you this. And that's a way of checking to see if your answer is correct. Now, I'm looking to see, there's best point estimate, find a confidence interval of the mean. Okay, I want to go through some problems to help you decide what you need to do, whether you need to use a Z or a T. So I just want to show you this. Notice we're talking about a mean. And notice it's standard deviation of a population. When that happens, you use Z. If you look at this one, notice I see the standard deviation. Think of Z. Notice this one, standard deviation of population, Z. Okay, now this one, standard deviation of a population, Z. Now, go back to 12, problem 12. Notice it says, when 14 different second-year medical students measured blood pressure of the same person, they obtained the results listed below. Assume that the population standard deviation, they just gave you a population standard deviation, so you use Z. On this one, assume the population standard deviation is known, use Z. And so you can see, I'm looking to see if any of these problems use T. Assume the population standard deviation. Okay. Now, this is where, in these problems, problem 16 on, they're wanting you to decide, do you use T, do you use Z, or do you use neither? So in this particular problem, notice The n is 26. The standard deviation's unknown, so that gives me a key about t, because the standard deviation is unknown. Since the sample is less than 30, I have to look at the next part that says, is it normally distributed? So here's the main thing. The standard deviation's unknown. That keys me into t. And it's normally distributed, so I can use t for this. Now, to find t, we need our table. Let me see if I can find the table. And we need to go to our t table. If I can find it.